So looks like we have a good number of people here. So welcome, everybody. On behalf of the Marnix E. Heersing School of Biomedical Innovation and Entrepreneurship, I want to welcome you to today's AI in Healthcare Rounds. The purpose of AI in Healthcare Rounds is to explore the latest advancements and applications of artificial intelligence and its transformative impact on healthcare and innovation. I encourage you to join the conversation and ask questions throughout the presentation. I am pleased to introduce today's speaker, Dr. Cynthia Lokker. Dr. Cynthia Lokker is a health research methodologist and researcher in the Health Information Research Unit, Department of Health Research Methods, Evidence, and Impact at McMaster University. Her research focuses on leveraging information retrieval and summarization approaches, particularly machine learning and natural language processing, to support evidence-based medicine and knowledge translation. She is the Faculty of Health Sciences Coordinator for the Interdisciplinary Master of Science in eHealth and has expertise in digital health and evaluating mobile health applications. Without further ado, Dr. Lokker, I'll pass it off to you.
Great, thanks, Christian, and thanks for the invitation to present. Slides up there. All right, and thanks everybody for attending. I'm seeing a lot of eHealth students in the participant list, so appreciate that you all came as well. So today I'll talk about leveraging AI to support evidence-based medicine. I won't spend too much time on this because I think Christian just did a great job on describing who I am and where I fit here within McMaster. A couple of disclosures. I do get some salary support from the Health Information Unit through contracts with the American College of Physicians and EBSCO. And like Christian mentioned, I'm a research methodologist, so I'm not a machine learning engineer and I'm not a clinician, so my viewpoint doesn't necessarily reflect those, but I try to understand those. And the work that I'll be sharing today is focusing on natural language processing. I would like to acknowledge that we are on the land of the traditional territories of the Mississauga and the Haudenosaunee nations within the lands protected by the Dish with One Spoon Wampum Agreement. The way that I am increasing my own knowledge about the history of Indigenous people in Canada is through exploring artists and the stories that they tell. And so I'd like to share with you that if you haven't been introduced to Shelley Nero, she's an Indigenous artist from the Six Nations and has very profound art recently showcased at the Art Gallery of Hamilton. So I certainly encourage you to get to learn about her. The agenda very briefly is I'll describe evidence-based medicine. We've got a mixed crowd, so I'll define evidence-based medicine and the different roles for machine learning. What we do here at the Health Information Research Unit, which I will call HIRU, one of our main processes is a health knowledge refinery. Describe some of our early experiments and some of the places we're going with machine learning. So evidence-based medicine is basically, and feel free to, I don't know that I can see the chat, but if somebody could cue me if there's a question that pops up. But evidence-based medicine is this intersection where a practicing clinician is making some decisions and having a conversation with the patients, and it takes into account patients' preferences and values and based on the best available research evidence. And that can vary by condition and situation. And the process of evidence-based medicine starts with that question. Is so having a need that the clinician has identified that they would like to understand better or look at the options for treatments. So the question is asked, they go and search for the evidence, so acquiring it. There's an appraisal step, making sure that the evidence is valid, effective, and applicable in the situation they're in. Integrating the evidence into the decision-making with the patient, and then seeing what happens, right? Auditing the outcome of the patient, and then that becomes integrated into the knowledge of the clinician and the experience of the patient. The problem, however, is that gathering all that evidence is not an easy task. There are over 30 million research articles in Medline. In 2021 and 22, there were pretty much 1 million new articles added to PubMed. So this is a huge influx of content, and it's really hard to find the quality evidence within that huge pool. And within that huge pool, there's also different levels of quality. And so this is the hierarchy of evidence. And depending again on the question, the answers might come from a lower level on there, but it's still the best that you have at the time. But it ranges from those individual studies and then the syntheses, synopses, summaries, and systems where we have knowledge integrated into our computerized systems. And so this is really the milieu where I am in a day-to-day basis, is how can we identify the high quality research studies and make them available to clinicians, because they're pretty busy, as we all understand, and they need access quickly. So there's a lot of different ways that machine learning and natural language processing is already being used in curating evidence for evidence-based medicine, and across, again, these hierarchies of evidence. So certainly with tasks of making retrieval of evidence easier from the big databases, identifying the relevance, classifying articles, doing critical appraisal, information extraction, etc. And the majority of the work that you will see is done for systematic reviews. This is a very active area of exploration and commercialization. It's a pretty busy slide here, but this is a really great mapping review done in 2022, where the authors have looked at all the different tools and resources that are available that support systematic reviews. So you can see this is an active area of both producing products, but also of research. And so along the continuum of a systematic review, there are tools that can support those processes. For example, in Covidence, many of us are using Covidence for systematic reviews. It now can automatically remove studies that are not randomized controlled trials. So if you're doing a review of treatment studies, you can automatically get those out of your screening list, and that makes your process that much more efficient. And it also has an active learning component. So for example, if you're not doing a treatment, well, for treatment, but for other kinds of reviews as well, it learns from the decisions you make on articles and then re-ranks them to bring the more relevant ones to the top. So this is, these are really great for making those systematic reviews easier to do or more efficient. And there's an enormous amount of work also just researching how effective these tools are, so we can make good decisions about what it is if we're integrating these into our reviews. Now at HIRU, our focus is a little bit outside of the syntheses. It's an active area, lots of really great work going on, but we're trying to see if we can make progress on doing that retrieval and classification appraisal of individual studies, and then also in text summarization tasks. So this is where our machine learning experiments and work is happening right now. Now, before I go too deeply into the work that we do, it's really important to understand what it is we do. So I'll give you some background. The Health Information Research Unit was founded in 1985 by Brian Haynes, who's here in the corner picture, and is currently directed by Alfonso Ayorio. And within HIRU, we have what we call the McMaster Health Knowledge Refinery. And that includes a number of processes that I'll end up describing, but as an analogy, a knowledge refinery is similar to an oil refinery. So imagine you've got usable and useful products that can come from murky, imperfect components, right? So we've got this whole vast number of articles in PubMed, but we want to be able to pick out the high quality ones, those that are done with with methodological rigor, but then also that are relevant to practice. And so through a very careful process, we can distill the high quality evidence through our refinery process. And then that then becomes available for other people, and they don't need to necessarily go through and do those steps of appraisal for those studies. So this is a flow diagram of what we do here in HIRU every day. So each night we have automatic searches of PubMed using Boolean search filters that were created within HIRU back in the early 2000s. So they're validated search filters to pull relevant articles. They go into a database. We have highly trained research staff who do the critical appraisal based on rules for evidence-based medicine. So if we're looking at a treatment study, we would be looking at, was it properly randomized? Did they follow at least 80% of the patients throughout the study? And did they report clinical outcomes? And for articles that meet those criteria, we then add a lot of extra metadata. So we would add ages, the disciplines that might be interested in it, the clinical disciplines, and SNOMED indexing terms, because that filters them to our end users further downstream. The articles are reviewed by a clinical editor who has research methodology expertise. And if we all decide this is good, this is relevant, it goes on to what's our MORE database. And this is the McMaster online rating of evidence. And within MORE, we have clinicians from across the globe. There's about 6,000 of them who will rate articles on a 7-point Likert scale on, is this a newsworthy article? Well, first of all, is it relevant to my practice? So again, with the SNOMED indexing terms and the disciplines, if I said this is important for respirology because it's a study on asthma, the clinician would say, is this relevant to my practice and is it newsworthy? Because some research studies might be sort of me too, it's not really new findings, but then others will be, yes, the people in my field should know about this. And so if they've got a mean score between 4 and 7, they go on into the PLUS database. And then from the PLUS database, we have both pull and push mechanisms to make this content available. And all of the articles, whether they meet rigor or not, go into our machine learning database for training. So broadly, that's or maybe that wasn't so broadly, that's very specifically what we do here. And then the articles that are from the PLUS database go into these, are sent out or made available through all of these services that we currently provide. So some of those are very specific, CLOT Plus, for example, for thrombosis doctors, but evidence alerts, for example, is for everybody, all practicing clinicians. So if you're interested, you can sign up for evidence alerts. There's the data repository, which you can search. There's email alerting system. And this is freely available and currently supported by EBSCO. You can also search through Access. Access is available for McMaster users and at other, because you can search the McMaster library, and it will actually give you your results according to the hierarchy of evidence. So just to give you a sense of the process of the filtrate that comes through our refinery. In 2019, we pulled in 59,000 records from PubMed, and those are, we focus on about 120 clinical journals. With the Boolean filters, this was reduced to just over 17,000 articles. And after we do appraisal and the relevance and newsworthiness assessments, that was just under 4,000 articles. So you can see there's a lot that comes through that we don't end up putting into PLUS because it just doesn't meet the quality standards, or it's just something that that doesn't fall within the scope of what we do literature surveillance for. And one of the stats that we use is the number needed to read. So this is 1 over precision. And so if you are a clinician, it's similar to the number needed to treat. It's the number of articles we need to read to identify one that meets criteria. So back in 2019, before COVID hit and publications went wild, we had to read 5 articles in order to find one. So that's an overview of what we do. And so you can see it's also a very laborious process. We do this within 2 weeks of an article going into PubMed, sorry. So it's very early in the stages. Medline, and they certainly haven't yet indexed to the article. There's no mesh terms and there's not a lot of other metadata about those articles, but we want to be able to give the highest quality, newest research through PLOS. And especially not just because of COVID, but just in general, we know that the system could be more efficient. And so a lot of what we were thinking about is how can we use natural language processing to help with our mission of getting high quality evidence to people who need it and get it to them quickly. And so we, just to reiterate, we're kind of focusing on retrieving, classifying, appraising, validating, and then summarizing. So this is where we started doing more and more of our experiments. And the beautiful thing is we have this amazing resource that we've accumulated over all these years. So from 2008 on, we have data on articles that we have assessed. For the articles, for all of the articles that meet or do not meet criteria, we know what types of article they are. So is it an original study? Is it a review? Is it a guideline? Or is it not one of those things, which could mean letters or commentaries, that sort of thing. And then for the originals, reviews, and guidelines, we also know which purpose category. Is it a treatment study or primary prevention? For those, we would look for randomized controlled trials. Is it a diagnosis study? Is it looking at prognosis of disease, et cetera? So we have this data on all of the articles. And we also have a rigor assessment. Does it meet criteria or not? So you can imagine this is a pretty amazing resource that we have curated over these years with our expert staff. And this allows us to be able to train models. And our first foray was using classical machine learning, some more regression-based approaches. I'll describe some deep learning that we do after this. And our objective in our first study was to improve the efficiency of the refinery to identify high-quality studies. And we trained a binary classifier. So a model that that gives us an output of, yes, this is rigor or not rigor. And we've set our sensitivity at 99%. So we can choose models that provide us with 99% sensitivity or recall, which means that we don't want to miss any potentially high quality studies. And the goal then is that we have more true negatives that we do not have to read, and that will increase our efficiency. For this experiment, we trained using data from 2012 to 2018, just about 100,000 articles. Our data set is unbalanced. There are 4.5 more articles that do not meet rigor than do. So we did some oversampling and undersampling, and we did we had our data set split into 80-20 for training and testing, and we had 2 external data sets that we could test it on, our selected models on, articles from 2020, and then a prospective evaluation that we did in real time. And so since this was all new to us and we were just learning, it was our computer programmer who was doing most of the running of the models, the training of the models, we first tried AutoML. So this is an automated process that tests the various configurations of our pre-processing options or features that we selected. And then it selects the optimal performers to keep and not keep. So it required less of our input as it was running. It runs these models sequentially. And like I said, we tested undersampled and oversampled, and the 6 different algorithms are in the square box here. Those were the ones that were available through Hugging Face at the time that would give us a binary probability score. And then we basically trained and selected the best model for each of the data sets, and then we put it together in a majority vote to give us the prediction for the articles. In all cases, the best performing model used light GBM. And so then when we tested this to see how well it would do prospectively, so we implemented it within our reading process. Our research associates were not aware that this was going on. They just continued their work as they would normally would. And in this validation, sensitivity was maintained at 99.5, specificity was 53%, and our number needed to read, you might remember before, it was closer to 5, and now it's 4 articles. So that improved our efficiency, and we implemented the light GBM model into our process. So this couple of years back now, but it saved 45% of the work. So the work saved over sampling is the percent of articles that are predicted negative that we didn't have to review. So that was a big win for us. And then we thought, okay, well, maybe we can do better. So let's do a deep dive into deep learning. And the next set of experiments ran fairly similar to the previous one. In this case, we were able to extend the data set to 2020, so we had more articles to use for the training. We still did some tests with trying to balance the data sets and using class weights. And then we were using the BERT-based variants. So these are bidirectional encoders. They are able to look at words going forwards and backwards, so they perform better than some of the other models. And there's also BERTs that have been trained on specific corpora. So PubMed BERT has been fine-tuned on articles from PubMed. BioBERT has been fine-tuned on scientific articles. So the premise is that they would perform better because they would have this similar language to what we're seeing. In all of our cases, we're only using titles and abstracts as our inputs for the model training. So it's title, abstract, and whether it meets criteria or not. That's the output. I'm not going to go into this, but if you're interested, this is in our publication. Just describes how we split the data and how we did our testing and model selection. Suffice it to say, one of the best performing model was a BioBERT model, and also not a majority vote one, just a single model. The majority vote didn't make much difference, and there's a reason for that makes sense, since they were all using basically the same data to train. But the BioBERT model had 99.7% sensitivity. Our specificity basically went up 20% from the classical models, and now our number needed to read is 3. So we've made another big gain in terms of the efficiency of our process, which has been great for us, especially during COVID. We expanded the reading of COVID to everything that was in PubMed, not just our 120 journals. So that was an amazingly large undertaking by our unit. And we've subsequently just switched them back to the 120 since there's been a slowdown. So that's what our process looks like. Again, I can't see if there's any questions, but if somebody you just speak up, I'm okay to be interrupted. And this was really very much an internal, how can we make the work we do better? So we weren't necessarily doing much outward facing on this. Although if you're interested, you can sign up. You can go to ml.mcmaster.plus and sign up. You need to register for an account. It's just so that we know who's coming in. And then you can put in, use the machine learning classifier. So it's the BioBERT classifier. You can either put in a list of PubMed IDs, or you can run a PubMed search directly. And it will give you an output that is either CSV or RSIS file that gives you the probability score for each article and a classification as 0 or 1 for rigor. And we do have this model also integrated in the services that we provide to some of our clients. So if they are searching outside of the 120 journals that we surveil, they're able to rank articles by probability of rigor. So we're pretty happy with how those series of experiments have gone. And now we're also looking at other ways that we could support a range of users and clients in terms of identifying the kinds of studies they need and when they need them, and the high quality ones, so that they can be more efficient in their own efforts. And so I mentioned before that for each of the articles, we have the type. We know it's an original article, a review article, or a guideline. Within those, we have the categories and the rigor. And so for all of these, we have the potential to, imagine there's somebody who just wants the latest guidelines on a particular clinical topic. So they might have a really good content search. We could predict whether it's a guideline, and then also give a ranking for whether it's a rigorous guideline or not. Same for any of these other things. A rapid review on a diagnostic test, prediction of articles that are diagnosis, and then within the rigor. So these are some of the models that we're working on, eventually to lead to a cascading model, but some of them might also just be used in isolation. So we're just coming to the end of training a multi-class model. So in this case, the model output gives a probability that sums up to 1 for each of the different. So across original review guideline, not experimental, the probabilities will sum up to 1, and then the one with the highest value is the one that it classifies it as. These are the number of articles that we had that we used in the training. We experimented with a number of hyperparameter settings, so batch sizes, epochs, learning rates, and seeds. We used class weights and unbalanced data sets. Again, we were using the BERT-based variants, so BioBERT, PubMedBERT, FlyBERT, BioLinkBERT. Ran over 2,000 experiments, and like I said, used the highest score for the classification. And because in this instance, an article can only be one of those classes. And so the accuracy is pretty decent, over 97% in all cases. We do see that sensitivity is lower for the guideline, which is not actually surprising because it's also the smaller pool of articles that we have, and they can be quite variable. So I imagine they can be harder to classify. And so this isn't looking at rigor, this is just as this article type, and then the rigor models would come after that. And so Owen's on the line today. He's part of his thesis, he's an eHealth student, will be training models for rigor for treatment and prevention studies. So these are ones that we expect to see RCTs that meet criteria. And also he's going to be training a model for rigor of review articles. And our programmer, Rick, is also currently developing the protocol for how we would do a multi-label model across the different categories of articles, because in some instances, an article can be more than one. So this is a different approach. So while we're doing this, we're also contributing to the literature around multi-class models, multi-label models, that sort of thing. So that's been good learning. Some other future stages that we're planning is bringing the human in the loop. So this is our Oracle, our research associates for the most part. if we bring back the articles to them that maybe we have low confidence scores in, right? So they go through the machine learning model, imagine our multi-class model, and it says, well, it's not really sure if it's an original or review, the ones with the low confidence, bring them to our oracles. They tag them based on their expertise, and then it becomes relabeled and the model can improve as it goes through this iterative cycle. So there's obviously some different changes we need to make to our interface to allow for the model to be doing continual training. But that's something that we're discussing how to do. So shifting gears yet again, this is looking at large language models for text extraction and summarization. Very active area, as I'm sure many of you are aware. And again, we're focused on the literature, not so much on clinical information that's available through EHRs, et cetera. So again, it's high quality studies and trying to get summaries out to people who need them. So one of our products is creating ACP Journal Club summaries. And we also write summaries for lay audiences for the Optimal Aging Portal. So we're just have done some preliminary work here. Initial work we did just at the end of last year with some colleagues at Manchester was taking 10 of the expert summaries that we've created here in Hiru. And we were testing to see how well a series of large language models, the ones that were available at the time, could generate a summary for a clinical audience. So based on focusing on evidence-based elements within the summaries. So we used a series of prompts. We only supplied titles and abstracts in the prompts. We did not supply the full text, but the prompts were general. Can you summarize this with important evidence-based information? We did one with more focus on evidence-based medicine. So, please include the PICO and measures of effect, et cetera. We asked GPT to create a prompt, and then we also asked a general one and asked it to keep it short. And then we had 2 human evaluators look to see how well those performed. Some of the key takeaways, we ended up using ChatGPT 3.5 based on preliminary results, but after full analysis, it wasn't really the best choice. But all of the models really struggled with presenting the confidence intervals and the standard deviations, right? Which is an important thing that we believe should be included in any summary for a clinician. There was a fair amount of redundancy, especially with the longer prompts. The summaries overall were okay, but they were frequently missing details. And so really needed a fair amount of editing. And our own assessment, we didn't have great agreement. So there's really a need for having better validated tools for evaluating text summaries. We did use this process in the production of, I think it was about 78 summaries of articles. So we used ChatGPT 3.5 to initially just pull out some of the information, and then those were heavily edited by staff here. And in the words of our editor, it's like she's not hiring GPT anytime soon. But we're going to explore this a bit further because certainly it was a rudimentary experiment, and I think we learned a lot. We are also working with a colleague at Birmingham, and we'll be doing some retrieval augmented generation with large language models for creating summaries of articles. And this has been funded by the Office of International Affairs here at McMaster. And this kind of brings me to what, hopefully we have an opportunity for some discussion at the end, is the concepts of responsible AI. And for us, the focus is on how do we ensure trustworthiness of Gen AI summaries, especially with the large language models. So this is a great paper by Zhang et al. On the challenges and some of the solutions we should be working on collectively. So you can see there's, if you're familiar with responsible AI, so accountability, causality, generalizability, fairness, et cetera, those are important elements to be not only thinking about, but integrating into your processes when you're doing AI work. And so, and we're starting to integrate better reporting and tracking of what it is we're using in our training and how we're doing it, and how we're making decisions in order to meet these principles. But there's a great opportunity here as well. You know, for example, accountability, so domain experts for evaluation and verifiable knowledge resource. So those are things that we're expert in, that we could support, especially within this trustworthy evidence. Creating new evaluation metrics. We clearly need work done there. Keeping the human in the loop. So I think this will be guiding certainly some of our bigger thinking as we carry on with our work. Just some of the lessons that we've learned. Collaboration is key. As I mentioned, I'm not a machine learning expert and I'm not a clinician. So having people around the table that can bring all those different perspectives has been priceless. We play around a fair amount. So we're like, okay, what if we do this? What happens? Which does mean we have to keep good notes to make sure that when we're finally on the track where we want to go, we know what led us to where we are. We're spending a bit more time on data quality, and also we'll be able to use our models to help improve the quality of our data as well. And quite honestly, I'm getting a lot of my knowledge from reading blogs because I feel like this is such a fast moving space that sometimes you wait for the literature and it's, we've moved on already. I'd like to recognize that this is obviously a collaborative effort from the various experts as well as our trainees. And so we've been supported by MyTax and McMaster. And just a hat tip to students who are working on these various projects. We've got a fair amount of work going on in the background to better understand machine learning in this space. And then I thought we could maybe discuss sort of people's ideas about NLP in practicing NLM, EBM, in ensuring responsible AI. And I did see that there was, can I stop sharing? I saw that there was a comment. Hi, Bushra, nice to see you. Yeah, so I think there's enough time for some conversation.
That was really fascinating. I do systematic reviews and meta-analysis, mostly pertaining to diagnostic test accuracy. And I'm already seeing so much potential overlap with what you're doing and what I do.
That's why these things are so beautiful, right?
Yeah, totally. And, you know, when we do these studies right now, I mean, I still do manual, like I go to a librarian, I have them construct a search. I'll do we end up doing manual. We have two reviewers kind of review everything, but this could save so much time. Have you, like, are there lots of deployments now for research? Are you seeing people use strictly AI to identify studies for systematic reviews? And then the other question I want to ask you is, I've recently been involved in individual participant data meta-analyses where we've gone back to study authors to get raw data rather than just info from the manuscript. But do you see any applications there? Do you see any applications pulling data directly from papers as well? Lots of questions there, but just curious to get your thoughts.
Yeah, so yeah, there were a couple of things there. Certainly, I think pulling data from studies, I can see that it's sort of that retrieval augmented generation, and Dr. Afzal is the person we're working with at Birmingham, and that's his expertise. But you know, things like baseline statistics from tables and outcomes, sometimes from figures or certainly from tables and text. Definitely, I see that that's coming. And probably not too far in the future. One of the biggest challenges we're facing right now is copyright issues and PDFs, right? And so that's a bit of a minefield of how do we navigate those things while we're training models. So I think that's going to be part of the issue. And then you mentioned IPDs, so individual patient data. I guess there's also this movement, right, to data, making our data more available in repositories. And so I think probably that's going to be the workaround as more and more journals, even just for one of these studies, we had to learn how to do that to make our data in a repository. So I think that's probably the way. And then obviously machine learning can help you with the analysis and that sort of thing. And there's a lot. I feel there's so many different ways that people are applying AI into research that we, some of it a bit surreptitiously, and some of it a bit more overt. But there's still, I think, just this unknown of how to do that well. And how to make sure it's right? Like it's doing it right. That's a crux for us, is we spend so much time on accuracy of our synopses that we, obviously the human, there's always got to be a human just to make sure.
It would be really, one thing that might be interesting would be to see if you can identify, or isolate studies that have publicly available data attached, like their raw data. Because that would fit, that kind of eliminates the need to reach out to the corresponding authors, and you could do IPD using that. It'd be limited probably, but anyways. But yeah, no, this is fascinating. Thank you very much.
Yeah, great. For sure.
Hi, Cynthia. I know I joined a little bit later, but I got a little bit of the last conversation. I'm sure the presentation was amazing, as I've taken your courses. But just to add to that question, essentially what I use currently is something called Ryan or Rayan. I don't really know what the right way to say it, but I know that they've been beta testing a lot of different features, such as reading through documents, not just with the OCR, but also sifting through them, summarizing them, telling you which ones are systematic review, scoping. And I found that to be really helpful. I've been using it since 2019. And the shift has been just dramatic in the last year, with them changing and rehauling the interface and just everything. And it's a collaborative platform, which means that a bunch of people can use it together for research. But I really found it helpful that it's now able to filter as well as tag these documents. And their new features also, and I, by the way, I don't work for them, but I just think that it was so helpful. It saved so much time for me, rather than me calling my supervisor or messaging them again and again, which is tedious. So definitely something to look into, as well as the Prisma diagrams that they also automate now, which used to take so much of my time, to be honest. And I really, really appreciate that feature because it cuts down the administrative tasks for you so that you can focus on reading. And I know that there's a lot in terms of double checking the information and making sure that it's tagging it correctly. But that's why we made sure to do it through Ryan and then also EndNote and kind of match them two together. But I could definitely see EndNote as well as something like Ryan moving even further than this, and to actually analyzing and suggesting articles is something that I was looking into the other day. So, and it's tricky with healthcare because you can't just use anything, and making sure that they're peer reviewed. Even if you do want gray literature, making sure that it's still correct information is difficult. That's why you have the manual process at the end, once everything has been cleaned essentially. But yeah, I thought that was really fascinating. And I think there's some cool tools out there. You just have to still be careful. Because I know, as you mentioned, with the PDF and the recent issues with Adobe happening is very interesting, because I didn't know that they were taking all that information. So Just a thought.
Yeah, I think that there's definitely going to be interesting, especially around the regulatory aspects, as information that we feed into models is being used and how it's being used, and whether you're doing that through an API or doing it like locally, where the information that you put in stays within. But then there's still also licensing agreement, especially with the publishers that we have through libraries. But yeah, there's a remarkable amount of work within systematic reviews, which is partly why we've decided not to go there, because everybody's, especially if they've got large buckets of cash behind them to be moving that further ahead and really quickly, and making great strides as you've just shared. The Ryan, Covenants, robot reviewer, like there's probably even more now after the LLMs have been released. Also a lot of work being done in doing question answering platforms using generative AI. And again, I've been to many of the platforms that are available online, and I'm from McMaster, and it's like digging into where are your citations, where did you prove this is actually giving you the right answer, and a lot of times you dig and you don't actually find the supporting evidence. So a cautionary tale.
Absolutely.
Yeah. Okay. All right, so folks who had to go, any other questions or? Looks like a fairly quiet ending to the last one for the season.
Great. Well, thank you so much for that. That was a really, really informative and fascinating talk. Thanks again, everybody, for joining us today. As many of us know, this past year we piloted these rounds, and we will be pausing them for the summer. A follow-up survey will be sent out in the next day or two to gather your valuable feedback on these sessions. Your input is crucial for our future planning, so please take a moment to complete it. Thank you. I want to remind everybody as well, you can watch this and past rounds on our Mac video page or on our YouTube channel, which is at Mac Health ICE. Thanks again, everybody, and enjoy the summer.